Welcome back to Let's Make a Game, the channel where we are making a computer role-playing game using the free program Twine and the Sugarcube format for Twine. As I demonstrated in my last video, I've added something to the game where you may leave the dungeon if you're at the starting space or the starting area, and you find yourself around some beggars and you have to decide how many shells, if any, you're going to give them. And if you're lucky and you don't give them enough, then you'll be fine. But if you are unlucky and don't give them enough, you may find yourself cursed, as in this case here where it says, for your stinginess, the beggars curse you to have a demon move into your head and shout foul suggestions which only you can hear, which has the effect of reducing your willpower by 4 points. And you can see here that the character now has a willpower of 4 out of 8, whereas of course they had 8 out of 8 to start with. And there are quite a lot of different curses if you do end up being cursed, and I would like to spend this video showing you a better way to handle the sort of branching where there's lots of different options, as in this case. So let's get into the code. And first I'll show you how I've been doing it. I've been doing this sort of branching in a couple of different ways, both of which work, but which probably aren't the best. So the first way I've been doing it is I might have something like this. We'll set Z equal to random 1 to 14, and that's enclosed within double, greater and lesser than brackets. Set Z equals random bracket 1, comma 14 unbracket. And then I would say, and each of these are within those same double, greater than or lesser than, if Z double equals signs 1, then do whatever that code is. Oops. Else if Z is 2, then do the next one. Else if Z is 3, do something else. And then we'd end with else if Z is 13, do the final thing. And then else, do the very last option. And then /if to indicate that the else, that this particular section of the code is over. The if command has ended there. The code that's relevant to it has ended there. So if Z equals 1, do this. Else if Z equals 2, do that. Else if Z equals 3, else if Z equals 4, etc., up to else if Z equals 13, so the highest number minus 1, do that, and then else, do something else. Or you could do else if Z equals 13, else if Z equals 14, do that, and then else, you might have something like print error, something like that. Now, you might do that, that's probably a good practice to get into. I must admit I haven't been doing it, but it is a good practice for when the range of variables isn't as obvious. So in this case, set Z equals random 1 to 14, and then immediately it's if and it's the ifs and else ifs. Well, it's going to be something between 1 and 14, isn't it? So I'm not really worried that it's accidentally going to be somehow 15. But if the value of that variable had been set somewhere else, then it might not be as obvious what the range of numbers is going to be, and so it might be worth having all of the possibilities as an if or an else if, and then but having an else at the end where, for example, you print the word error exclamation mark or something to let you know when you're playtesting that something's happened which wasn't what you expected. So that's one way that I've been doing it. Another way that I've been doing it is something like this. We go if random 1 to 14 is 1, then we do one sort of code, and then I say else if random 1 to 13 equals 1, do some other set of code. Else if random 1 to 12 equals 1, do something else, and of course we'll keep doing that, reducing the maximum number by 1 each time, and finally we'll get to else if random 1 to 2 is 1, and then else, and then slash if. And if we do it that way, reducing that number by 1 each time, then each of the options will be equally likely. So if random bracket 1 comma 14 unbracket equals 1 within the two greater than or lesser than signs, and then we have one bit of code, and then we have basically the same except it's else if and it's random 1 to 13, and then else if random 1 to 12, and so on down to else if random 1 to 2 equals 1, do this, else do the final thing. And if you work out the maths, you'll find out, you'll realise that each of these possibilities is equally likely if the randomness is truly randomly distributed. And either of those will work. But there is a better way, slightly better in that it requires slightly less typing, and it seems to be easier for the computer to execute, and that difference is probably not going to be very important if your game is quite simple, because the differences are in fractions of a second. But if you have a very code-heavy game, then those differences perhaps can add up. If it's doing sort of dozens of these things every time it does something, then these differences might add up, and that might be relevant. But it's mostly just slightly sort of easier on the fingers when you're typing it, and slightly more easy to follow what's happening. And here's what it is. So within the double greater than and lesser thans, we have switch, and then in this case I've got random 1 to 14. We could also have switch z, having set the value of z earlier. We could also have switch something like random 1 to 6 plus random 1 to 6. That would give a distribution between 2 and 12, but 7 would be much more likely than 2 and 12, and then 6 and 8 would be slightly less likely, and then 5 and 9 slightly less likely again, and so on. That might be useful if you wanted particular events to be more likely and others to be unlikely, but I wanted the events to be equally likely, so I went switch random 1 to 14, and then within those double greater than or lesser thans, I have case 1, which means if this number here is 1, case 1, and then the code that is to execute if it is 1, then case 2, sorry, I haven't highlighted all of it, there we go, case 2, execute all of that, case 3, execute all that, and so on, up to case 14, which is that code there. And it is not compulsory to have this final one where after case 14 I've got double greater than or lesser than signs, and within them I've got default, and I've had it in that case print error in cursed, and that's just to let me know that something's happened which I didn't expect, that the numbers have somehow gotten within a range that I didn't think they would get into. Now this one's quite simple because it's switch random 1 to 14. Well, I can look at that and know, well, the possibilities are that it's going to be between 1 and 14, isn't it? But if I forgot to write down case 7 or something, if I accidentally went straight from case 6 to case 8 or something, that would let me know that there was an error. Or if it was a variable and the variable was set a little bit before there was some code in between, and it might have some outcome that I didn't expect, something like that. It might be that might generate an error, and so it would be useful to have. It wouldn't generate an error. That's the problem. It would execute, but it wouldn't do what I wanted it to do, and so that's the point of having that default there. So it's unlikely to be relevant as it is, but I've put it in there just because it's a good practice to have if I was doing something more complicated. So I would recommend doing that. Now, the other things I would say are you can have multiple values in a given case. So you might have, instead of case 9, you might have case 9, 10, or 11. And then, of course, in that case, you'd get rid of this case 10 and case 11 because they would never happen, because this case 9, 10, 11 would sort of be picked up first. But if you had case 9, 10, or 11, that would obviously be 3 times as likely as the other cases. So that's another way to make particular outcomes more likely if you want to do that, if you want to have a distribution that isn't even. And the other thing I should say is it doesn't have to be numbers. If it's something like this where it's like a random event and you're generating a random number and then the different outcomes will depend on numbers, well, obviously using numbers is going to be a lot easier. But the outcomes, the cases, can be text. So you could have, for example, if you had different races in your game and the outcome was different based on what race the character was, you could have case, quote, human, quote, and then have what happens to a human, and then you could have case, quote, elf, quote, and case, quote, dwarf, quote, and case, quote, halfling, quote, etc., etc. So that wouldn't be like a random table. That would be more like an event in your game where an NPC will treat different races differently or different classes differently or something like that. And just to remind you, I did show you, but I didn't point it out, and I should have. If you're doing something like case 9, 10, and 11, don't separate 9, 10, and 11 with commas. You have to use spaces. So case 9, 10, 11 won't work. It has to be case 9, space 10, space 11, or whatever the numbers may be. So that is Switch. It is, as I say, slightly better than using a series of ifs and else ifs, or using if random 1 to 14, else if random 1 to 13, etc. This game that I'm doing is probably going to be simple enough that it wouldn't be worth going back and changing what I've done to be cases. But if you're going to make if you're going to make a code-heavy game, the advantages of this might add up and might make your game run a bit faster and be a bit easier to type in and be a bit easier to look at what's happening. So I hope that is of use or interest to at least some of you, and I hope you will tune in next time.